Geometry Topic 7, flashcards. This is all about similarity. Dilation. A dilation is something that gets bigger or smaller. And what happens is when you increase in size, the shape still looks the same, just bigger or smaller. So it doesn't distort it in any way. Center of dilation is literally the center in which the figure is dilated. So if you look at this picture, this point right here, point O, is the point or center of dilation from which the shape increases in size or decreases in size. Scale factor. Scale factor is just the amount in which a shape is dilated. So if I am dilating my shape to be, let's say this example is times 4, that means I would multiply all 4 sides by the 4 because that's the scale factor. And so it's the amount in which you are increasing, or the ratio in which, not an addition or subtraction, but a multiplication or division. What happens if the scale factor, that R, is 1 in a dilation? Well, a scale factor of 1 means if I'm multiplying by 1, it doesn't really change anything. So nothing actually happens visually. So a scale factor 1 leaves the shape exactly the same. You cannot tell the difference at all. What happens if R, the scale factor, is greater than 1? That means you're multiplying by a number that increases the size. So it actually becomes larger. So if this is the pre-image, the image is then larger because the scale factor is greater than 1. Okay, if the scale factor R is between 0 and 1, so it's a fraction between 0 and 1, then the shape actually gets smaller. So it decreases in size. This is the pre-image and this is the image. So it decreases in size or shrinks. What is preserved? Preserved means stays the same. So the one thing that does not change in a dilation, no matter how big or how small it gets, the angles stay the same. That's really important to know. So if you look at these triangles, the corresponding angles have not changed at all, even though the side lengths change. And honestly, that is what makes the shape stay looking like the original, just bigger or smaller. If those angles changed at all, the shape would be completely distorted. What does it mean when the sides are proportional? So that word proportional, we are not talking congruent sides in dilations. We're talking proportional. So let's look at this picture. It means the number or in which I multiplied to get bigger, that scale factor is creating a proportional new object. So if I multiply all the sides by 2, except maybe one side I multiply by 5, then the sides are not proportional. There's not a scale factor that you can multiply everything by to get the new shape. So proportional means there is a number or a scale factor that everything is multiplied by to get that new image. In a dilation, side lengths are blank and angles are blank. I just went over both of these, but let's look. Those side lengths should be proportional. So it should have a number that multiplied or divided will get you the original or get you the image after the fact. And the angles are preserved. So those proportions, when you divide out the sides, like ED, this side, divided by BA or AB, if I divided this by that, I would get the same number dividing DF by AC. Or EF divided by BC. So taking corresponding parts, and if I divided them, I would get the same ratio simplified, and it would give me the scale factor. So those sides have to be proportional. Similar figures actually are just the result of a dilation. So you can have similar figures that are exactly the same. That would mean a scale factor of 1. You can have an increase, so from this pre-image to that image, it increased in size, so that scale factor is larger than 1, or you can have a shape that decreased in size, and so that scale factor was between 0 and 1. Similarity transformations. So transformations we've learned before, there's reflection, rotation, and translation. But now we have that similarity piece. So what that means is you're throwing in a dilation in there. So you can have reflection, rotation, translation with a dilation. So any combination. So here's an example. this hexagon increased in size, and if you can tell, it rotated. So it's a dilation with a rotation. So any combination of those with the dilation. Rules that prove triangles are similar. So there are only 3 rules. Previously, we learned 5 rules that proved triangles were congruent. These are not the same. These are 3 rules that prove they are similar. And to make sure that you know the difference, I recommend putting that little symbol right here, right there, similarity. Put that symbol after the rules. So angle, angle, similarity, side, angle, side, similarity, and side, 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 similarity. And we'll talk about each of those. Angle similarity. That literally means there are 2 angles that are identical to 2 angles in another triangle, and that shows that they are similar, which honestly, there's another theorem that's called a third angle theorem, which if you have 2 angles that are the same, this third angle has to be the same because they would have to add up to 180. So some teachers say angle, angle, angle similarity, because it really makes all 3 angles the same. But the real rule is angle, angle similarity. Because if you know 2 are the same as the other 2, then the triangles will be similar. And all the angles will actually be congruent. And that's where the triangle sum comes in. So you have to remember that adding up all those angles equal 180. So if that ever happens and you have 2 that you know the angles of, you can actually find that third angle. Side, side, side similarity. This is not the same as side, side, side congruence. In side, side, side congruence, we had to show that all 3 sides were exactly the same as all 3 sides of another triangle. Well, with similarity, we have to show that they're proportional. So if you look at these fractions, that's basically saying this purple arrow, when I divide these 2 sides, or I do the blue arrows, those sides, or the red arrows, when I divide those sets, I will get the same number every time. That means they are proportional. Side, angle, side. Order matters. So you not only have 2 sides that are proportional, that angle in between them has to be congruent. So it's sides that are proportional and the angle in between will be congruent. Okay, this theorem is intense. So watch carefully because the picture is kind of over the top. If you have a right triangle, and I'm going to have you look right here, and you have this altitude, so that line that goes straight up and down, it actually breaks up the triangle into 3 similar triangles. So this side right here on the right, it turns into this small triangle. And this side on the left turns into that triangle. And then the whole triangle, just as this one, it's just all facing the same way. And knowing that all 3 of those triangles are similar, you can actually find for missing parts. So if you have an altitude of a right triangle, it creates 3 similar triangles. And when you're using those 3 similar triangles, you use the geometric mean. And here's the equation, but it helps you find the missing parts. So when I teach these lessons, I just have students draw the small, the medium, and the large right triangles. And then I just have them match up corresponding parts and create cross multiplication problems to solve. And so they don't have to memorize this geometric mean, but talk to your teacher. Maybe you need to. Side splitter theorem. This is for triangles, and it literally only deals with the sides of the triangles that are being split. So if I have 2 parallel lines, and these are sides of triangles, and they're sharing a common angle, I can say, in using this proportion, A over B, it will be the same as C over D. Those parts are proportional by the side splitter theorem, but be very careful because you cannot use this theorem when you're using the parallel sides, only the sides that are being split. A triangle mid-segment, very similar to when we did trapezoid mid-segments, but this is a triangle. So you take this, that you have the parallel sides of the 2 triangles, and when you have that base and that mid segment where it's the midpoints of each side connecting, so DE is the segment that connects midpoint to midpoint, it creates a formula where this DE will be half of the overall base. So they're a proportion of double or half. So if I have the mid segment, I multiply by 2. If I have this side length, I would divide by 2 to find the other. And the last one is the triangle angle bisector theorem. Now, be really careful. All three of these triangles, like the small, the medium, and this large one, they're not all proportional. They're not all similar, but side lengths are proportional. So be really careful. So this formula says if this angle is bisected in any kind of triangle, if one of the angles is bisected, A compared to B is going to be the same as C compared to D. I know that other teachers say C over A is congruent to D over B, which will also get you a similar answer and it will be fine. But just be careful. The formula actually is A over B is the same as C over D. And like always, I have left you some blank flashcards where you can add your own. I hope that helps.